Okay, so now we're talking about step 5, which is drafting the analysis. In reality, this is inherently a iterative process. You don't just have a blueprint of what you want to analyze and do it once and be done with it, right? You have to do it over and over again. So the things to consider when you're planning your analysis include what statistical tools you can use to address the question, how will the results be presented, whether it be in figures or tables or what have you. Well, control analysis should be run so that your results can be compared to a control control run. And lastly, what follow-up questions should be asked depending on the results that you see. So the first consideration when you're drafting analysis, what statistical methods can you use to test maybe the relationship between two variables such as CO2 and temperature, right? So in the Colab notebook, you'll see that we use as example two records, both of them 800,000 years long, of atmosphere CO2 and atmosphere global temperature. So we want to think about what kind of statistical method we can use to test the relationship between these two variables. And number two, how will the results be presented, right? The most basic form is a figure, and probably the most basic form of figure will be some sort of line figure or scatter plots, but you can also do all sorts of other figures, including bar plots, pie charts, what have you. Or some audience might prefer to actually see the numbers of your results rather than just seeing them as a data point on a figure. So in that case, it might be easier and more suitable to actually put those numbers in a table and present your results that way. And here we want to just talk a little bit about your color choices in the figures. So a sizable population of the world actually suffer from one or more color vision deficiencies. And for them, it might be misleading and difficult to read color plots when the wrong color map is used. In the early days of scientific publishing, when color printing just became available, a lot of authors like to use rainbow color because it's just one color map with all the colors you can come up with. But in reality, it is rainbow colors are actually really hard to read, even for those without a color vision deficiency. So the solutions here is to use a perceptually uniform color map, and you can read more about the definitions of these in the notebook. Or alternatively, you can just use different marker or line styles to distinguish the different records. So maybe use a solid line versus a dashed line for two different records. Okay, so number 3, what control analysis should be run. So here we want to think about whether the results are robust against removing the long-term trend in what we call detrending of the data, or whether the results are robust after you select the shorter time periods or using some sort of running mean average, right? So just to control analysis is what you do when you want to make sure that the results that you see is defendable with alterations of your data. Lastly, you want to think about what follow-up questions could be asked depending on the results. Again, right, analysis inherently is iterative, so it's very natural to have follow-up questions and then do more analysis depending on the results that you see in your initial analysis. So, right, basic one here would be whether correlation is the same as causation, and the short answer is no. And you'll read more about this in the text in the notebook. And right, another follow-up question will be something like whether you could see the same trend between atmosphere CO2 and temperature in even longer timescale records, right? So these are the things that you want to consider when you are thinking about how to draft your analysis.